All right, so today we are moving on. If you guys remember from Monday, we briefly went over, that's right in front of you, sorry. We briefly went over all the different transformations in the order matters, H, S, R, V. We did the H, the horizontal translations, on Monday. Today we are doing the S and the R. So first, dealing with the S. These are vertical stretches and shrinks. So the S is for stretch and shrink. So the S part of HSRV. This is when your graph gets either taller for a stretch or shorter for a shrink. And so with the horizontal translations that we did Monday, we can identify those by addition or subtraction that happens inside the parentheses. With stretches and shrinks, they are denoted by multiplication. That happens outside of the parentheses. So it's whenever a number is being multiplied on the outside. So in order for it to be a vertical stretch, so our graph gets taller, or it gets taller quicker, or it increases quicker. A vertical stretch is when we multiply by a number that's greater than 1. So any number that's bigger than 1 would be a vertical stretch. For a vertical shrink, again, this is when our graph gets shorter. This is when you multiply by a number less than 1, but both of these are still positive numbers. Stretches and shrinks are only with positive numbers. We're going to be dealing with the negatives separately. So this vertical stretch and shrink, always going to be a positive number. We just care if it's greater than 1 or less than 1. Okay, so for a linear function, there's kind of two ways that we can look at this. One is when we have the parentheses. So if we had 3 and then in the parentheses x, again, this is multiplication. Or if there's no parentheses at all and it's just 3x, that would be the same as well. So this would be a vertical, you can just write v instead of vertical stretch because 3 is greater than 1 by 3. Okay, for a quadratic, same idea. We can have the parentheses around the x squared, but it doesn't have to be there. We could just have 3x squared. Since there's no parentheses grouping the 3 and the x together, that means the 3 is not being squared, only the x is, and so that's why 3 would be considered on the outside, even if we don't explicitly have these parentheses there. If the 3 isn't being squared, it's on the outside. This would also be a vertical stretch by 3. Then for square root and absolute value, the number that you're multiplying by would just have to be outside of that symbol. So for square root, we would just have 3 square root of x, or again, it could be f of x equals 3 square root of x. Again, this is multiplication that's happening, so that's why it's a stretch. And 3 is greater than 1. And then same idea for absolute value. The 3 is just outside of those absolute value bars. That would be a vertical stretch. Okay, So vertical stretch when you're multiplying by a number that's bigger than 1. For a vertical shrink, this is when we're multiplying by a number less than 1, still a positive number, but less than 1. So if we had y equals 1/3 x, or f of x equals 1/3 x with no parentheses. So it'd be a vertical shrink. There's two ways that this is said sometimes, so you just have to be okay with both of them. It can be said vertical shrink by 1/3. That's the number that's out in front of x. Or sometimes they'll say a vertical shrink by 3. And so even though 3 is a number bigger than 1, since it's a shrink, that means it has to be a fraction. So it would only say the by 3 if it was 1 over a number. But just know if you see the word shrink, whatever number you're multiplying out in front of that function has to be less than 1. So if it's a vertical shrink by 3, you can't put a 3 out in front because 3 is bigger than 1. So you have to be okay with both of those. With quadratic, again, we sometimes can have the parentheses grouping that x squared together, so it's obvious that the 1/3 is out in front, not being squared, but it won't always be there. Sometimes it'll just be 1/3 x squared with no parentheses, but since there is no parenthesis grouping the 1/3 and the x together, only the x is being squared. So since the 1/3 is not being squared, that would be considered outside of the function, of the squared function. Okay, and then square root absolute value, again, same idea. The multiplication happens on the outside, and it's just a number less than 1 this time. So 1/3 square root of x, or 1/3 absolute value of x. Okay, so any multiplication that happens outside of the parentheses or outside of the function would be a vertical stretch if it's greater than 1, or shrink if it's less than 1. Okay, so that's the S part of HSRV. Now we're going to talk about the R part, the reflection. So the reflection is where a graph is either going to reflect over the x-axis or the y-axis. So reflections are where the negative signs come in. So reflections are denoted by the negative sign. So just the negative sign by itself is a reflection. Any number that it's in front of would be the stretch or shrink. So again, stretches and shrinks are always positive numbers. The negative we deal with the reflection. So if we have a negative outside of the parentheses, that reflects over the x-axis. And if we have a negative inside the parentheses, that reflects over the y. Okay, so for what it would look like for these different functions, again, reflection over the x-axis means it's outside. So we'd have y equals negative x, or f of x equals negative x. Again, if there's no parentheses grouping it together, it's assumed to be outside. So since it's on the negative is on the outside here, this is what reflects it over the x. For a reflection over the x-axis, this negative would be the very first thing that you say if you were reading the equation, like negative 3x or negative 2x plus 7. If the negative is the very first thing that you say when you're reading it, that would be a reflection over the x-axis. So with quadratic, again, sometimes there will be parentheses around the x squared part, sometimes there won't be, but if there's no negative, or if there's no parentheses grouping the negative and that x together, only the x is being squared, so that negative would be considered on the outside. And then square root and absolute value, again, is a little more obvious as to what constitutes being outside. It's going to be right in front of the square root and absolute value symbol. So y equals negative square root of x, or f of x equals negative absolute value of x. So the negative sign is just not inside the square root, or it's not inside the absolute value symbols. Okay, so again, negative on the outside reflects over the x-axis. When we reflect over the y-axis, this is where the negative is on the inside, right next to x. So this is where we have to have parentheses grouping the x and that negative together. Or with quadratic, again, there'd have to be parentheses grouping it together, so the negative and the x are both being squared. And then with square root and absolute value, the negative sign would just be underneath or inside of those symbols right next to x. So y equals square root of negative x, or y equals absolute value of negative x. Okay, so again, stretches and shrinks are numbers that are being multiplied, positive numbers that are being multiplied. Reflections are any negative signs that we're dealing with. So we go on to the next page. I'm going to write down my order up at the top just so I remember. H, S, R, V. We haven't done V yet, but it's a good habit to get into writing it. So H, just so we remember, is addition or subtraction inside. Stretches and shrinks are multiplication outside. And reflections are negative signs. Negative signs are different than subtraction. Okay, so for the graphing part, again, remember we can use our calculator to help us and do most of the graphing for us. Example 1, we want to identify and graph the parent function. So if I have the parent function equation, f of x equals x, what is the name of this parent function? If it just equals x. Linear. So then again, you can use your calculator to graph it. With under the y equals button, you would just type your x for y equals x. Then you can hit the graph button, see what it looks like. And then hit second graph to look at the table to get some points. But again, the parent function for y equals x will always be the same. So graphing parent functions, that's nothing new. If we look at letter B now, we have our transformed function, f of x equals 3, and then in parentheses, negative x. I want to first describe the transformations here. So what we have happening is, first we have to just look at what's different between our parent function and our transformed function. So we have two things that are different. We have this 3 on the outside, and we have this negative on the inside there. So that 3 is being multiplied by the x, because parentheses, again, if there's nothing in between a number and parentheses, that means multiplication. So multiplication means we're either going to be stretching or shrinking. And since 3 is a number that is greater than 1, this would be a vertical stretch by 3. And when we describe the transformations, we have to go in the HSRV order. So there wasn't any H, there were no numbers being added or subtracted on the inside. So the next thing we would say would be our stretches and shrinks. And the third thing we say now is our reflection, which is this negative that's happening on the inside of the parentheses. So since it's on the inside, we reflect over the y-axis. Okay, so then we can graph that in our calculator. So you do 3, then in parentheses, negative x. Make sure you use the negative sign, not the subtraction sign. And so when you graph it, you can look at it on your graph and then use your table to get some points. So you should see that the line is steeper because it's stretching, it's getting taller quicker, and then it also flipped over the y-axis as well. So it's steeper because of the stretch, and we reflected. So again, always double check that your transformed graph did what you said it should do. Example 2, if we have the parent function f of x equals square root of x, what is the name of that parent function? Square root, because there's that square root symbol. So to graph it, you go to y equals. Remember to get the square root symbol. It's the second x squared button to get that square root. And then you type your x and close your parentheses or hit the right arrow to scooch out of the square root symbol. Second x squared. And then you can look at your graph, use your table to get some points. And these 4 parent functions, the parent function graphs will look the same always. So once you start doing more problems, you might not need your calculator as much to graph the parent functions at least. So now letter B, we want to write the equation for the function that vertically shrinks by 2 units and reflects over the y-axis. So we still need to make sure that our new equation has the same parent function. So we still need that square root symbol, because our parent function was a square root, so our transformed function needs to be a square root, and then we can worry about doing all the stuff with the transformations. So if we are vertically shrinking by 2 units, since it's a vertical shrink, that means we have to multiply by a number less than 1. So if we're shrinking by 2, that means we would multiply by 1/2, because we have to have it be less than 1. And vertical stretches and shrinks are multiplication that happen on the outside. And then to reflect over the y-axis, reflections are negative signs. And over the y-axis means we're going to be on the inside. So inside your square root, you'd have negative x. Okay, so then in your calculator, you can graph that. You type your 1/2, and then your second x squared button to get the square root symbol, then negative x. Make sure the negative and the x are both underneath the square root symbol. Go the other way. Yeah. Yeah, again, with square roots, there are going to be errors, so you just got to keep finding it until there's the non-error ones. And then when you graph it, you should see that it does reflect over the y-axis. And it gets a little shorter. It doesn't increase as quickly as the original function because we had a vertical shrink. So again, always make sure that what you have graphed matches what you said should happen. All right, example 3. What is the name of this parent function? No, it's absolute value, the absolute value bars. So to graph it, use your calculator. Again, remember to get the absolute value bars, you hit the math button, go over to the NUM menu, and then it's the first option, ABS. Then you put your X either inside the bars if your calculator has the bars, or close the parenthesis around the X if your calculator has the parentheses. Then use your table to get some specific points to plot. Second graph. Okay, and so now if we look at our transformed function, we have to just look at what's different from our parent function, and we have two things that are different. We have this negative sign. Remember, negative signs are their own thing, and we have this 4. So the 4 is being multiplied on the outside, so that is a stretch or a shrink. That's the S part of HSRV, and then the negative sign is a reflection, so that's the R part. So when we describe our transformations, we have to go in the HSRV order. So there's no H's in this at this point. There's nothing being added or subtracted on the inside. So the next thing we would list is our stretches and shrinks. 4 is a number that's bigger than 1. So this would be a stretch. So vertical stretch by 4. And then the negative sign is on the outside. So this is over the x-axis. We reflect over the x-axis. Okay, order matters. You have to describe the transformations in that HSRV order, because if you were to do the transformations in a different order, you would end up getting a different final function. So order is very important, just like with order of operations. HSRV, make sure you remember that. Okay, then to graph our transformed function, in your calculator you would do your negative sign, and then 4, and then your math, NUM menu, ABS to get your absolute value bars. To graph it, and you should see that your graph does indeed reflect over the x-axis, and it's getting taller quicker, it's skinnier. So again, always make sure that it did what you said it should do. And example 4, what is the name of this parent function? Quadratic, because of the squared. So remember, to get that squared, you just hit the x squared button, and it will square it for you. So in y equals, to graph it, you'd hit your x key, and then the squared. And then use your table to get some points. And connect your dots, nice U shape. And then for our transform function, again, we just care about what is different. So there's no h, there's no addition or subtraction being added inside those parentheses. But we do have an s. We have this 1/3 that's being multiplied. Again, just the 1/3. S's always have to be positive numbers. The negative is a reflection. So negatives are their own thing. Okay, so we go in our HSRV order. There's no h. So S is next. 1/3 is a number that's less than 1. So this is a shrink. So vertical shrink by 1/3, or you can say by 3, as long as you have the word shrink. Then the reflection of the negative sign is on the outside, which means we reflect over the x. So to graph it, we would just type that in your calculator. So your negative sign, and then 1 divided by 3 for your 1/3. Then parentheses, x, close the parentheses, and the x squared key to get your squared. And then graph it, hit the graph button, look at it, look at what it looks like, and then use your table to graph some nice points. Oops. Okay, and you should see that it does indeed reflect over the x-axis, and that it's getting shorter. It's not increasing as quickly. It's fatter. All right. So the next example, again, we eventually are going to get to the point where we have all the HSRV stuff happening all at once. So we need to be able to pick out each of the individual transformations. So right now I just want to focus on finding just the vertical stretches and shrinks and reflections. So vertical stretches and shrinks are any numbers that are being positive numbers that are being multiplied on the outside. Positive numbers being multiplied on the outside. And then reflections are negative signs, not subtraction signs, negative signs. So for letter A, what part of this equation here is a vertical stretch or shrink? Yeah, Devin. The +7 is a horizontal translation because that's addition happening on the inside. Remember, vertical stretches are multiplication that happen on the outside. Andrew? The 3. Yeah, just the 3 because it always has to be the positive number. And then we have the negative out in front, which is the reflection. So 3 is a number that is greater than 1, so this would be a vertical stretch by 3. And then the negative is on the outside, so we reflect over the x. Okay, for letter B, again, we only care about vertical stretches and shrinks, so multiplication that happens on the outside of the parentheses. So in this case, it's just the 1/3 that's out in front. 1/3 is a number that's less than 1, so this would be a vertical shrink by 1/3. Or you could say a vertical shrink by 3, as long as you have the word shrink. And then for the reflections, we just need to find negative signs, and we have a negative inside the parentheses here. since it's on the inside, we reflect over the y-axis. And letter C, again, for vertical stretches and shrinks, multiplication that happens on the outside, so it has to be out in front of our absolute value. So it's this 4. The negative signs, in this case we have 2 of them. We have one on the outside and one on the inside. So 4 is a number that's greater than 1, so this is a vertical stretch by 4. But then for reflections, we reflect over the x and the y-axis because we have a negative on the outside and a negative on the inside. Okay. Example 6. So now we're going to have, again, focusing on our H, S, and R transformations. So we first want to identify the parent function, then describe the transformations, and then graph our transformed function. So A, f of x equals negative 1/4 times the absolute value of x plus 2. What is the parent function of this equation? Absolute value, because we have these absolute value bars. Okay, then for the transformations, again, order matters, H, S, R, V. So we need to go through. H is any addition or subtraction happening on the inside. Do we have any of that going on? Yes, we have a plus 2. That's our H. Our S is stretches and shrinks. That's multiplication happening on the outside. We have the 1/4 that's being multiplied on the outside. Again, it has to be a positive number. And then the R is for reflections, which is negative signs. And we have one negative sign on front. Okay, so then we have to list our transformations in the HSRV order. So we would do our H first. We're adding 2. So if it's a plus 2, that means we move to the left 2. For the stretch or shrink, it's 1/4 that's being multiplied. 1/4 is less than 1. So this is a vertical shrink by 1/4. And then the negative sign is on the outside. So this reflects over the x-axis. Okay. So to graph the transform function, again, you would just plug exactly what's there into your calculator into y equals. So you'd have the negative sign, then your 1 divided by 4 for the 1/4. Then to get those absolute value bars, you go math, NUM, ABS, and then make sure that x plus 2, that's all happening either inside the bars if you have the actual bars on your calculator, or make sure you close the parenthesis after the plus 2 if you just have the parentheses. Then you graph it. And you should see that it moves to the left 2. Again, use your table to get some specific points. Okay. And again, you should be able to tell based on what the parent function would have looked like. Our graph usually starts at the origin, so it did move over 2. It did reflect over the x-axis, and it did get shorter. It's not increasing as quickly as the regular parent function. All right, go ahead and skip letter B for right now. We'll just go to example 7 to practice writing these equations. So the important part about writing the equation is that it matches whatever parent function we're dealing with. So for letter A, we want a quadratic function. Quadratic is x squared. So that means whatever equation we're writing, we have to have something squared. We have to make sure that it matches the parent function. We want to translate left 2 units. If we move left, that means we're going to add 3 on the inside. So we'll have x plus 3. Then we vertically stretch by 2. That means we're going to multiply by 2 on the outside. And we're going to reflect over the x-axis. So a reflection is a negative sign. And over the x-axis means on the outside. Just put a negative out in front. Okay. Letter B, the function y equals square root of x. That's our square root function. We need to make sure that we have a square root in our transformed equation. So always start there. And we might as well put our x there as well. And then now we can worry about our other transformations. So vertically stretch by 2 means we multiply by 2 on the outside. And then reflect over the x and y axis means we'll have a negative sign inside and outside. So we have a negative out in front of the 2 and a negative in front of the x. Let's do one thing at a time. Absolute value is the bars. So when we have our transformed function, make sure you have those absolute value bars, the x in there somewhere, then we can do our other stuff to it. But you have to make sure you have those absolute value bars. Translated right 1 unit. Right means we're going to subtract 1 on the inside. So I'll have x minus 1. Then vertically shrink by 3 units. Since it's a shrink, that number has to be less than 1. So this will be times 1/3 on the outside.